To light an LED, you will need 4 basic components: an LED, a battery, a resistor, and a switch. Many people are not familiar with LEDs or resistors. An LED is a device that transforms energy into photons or light. A resistor reduces the electrical strain in components by reducing the electrical charge. Start by making a schematic, which is a diagram that lays out the components of your circuit. Familiarize yourself with the schematic symbols for an LED, battery, resistor, and switch. This is an example schematic. Notice how the electricity flows from positive to negative, ending with the LED. A basic understanding of electrical theory will help you choose the right resistor. You will need to know how to differentiate series and parallel circuits. A series circuit, like a string of Christmas lights, only has one path for electrons to flow. A parallel circuit, like an extension cord, has multiple paths for the electricity to flow. This LED circuit is in series. In the future, it will be important to remember that resistance adds in a series circuit. Using the Ohm's law triangle, you can derive the equation resistance equals voltage divided by current. This equation will determine the type and number of resistors you will need. To solve this equation, you will need to find the values for voltage and current. Google the model of your LED to find the amount of electricity needed to turn it on, as well as the current of the LED. V will equal the amount of voltage given by your battery, which is 9 volts, minus the power required by your LED. For my standard red gumdrop LED, I found the voltage to be equal to 7 and the amps to be equal to 0.02. I plugged these values into the Ohm's law equation and found the required resistance for my circuit to be 350 ohms. With the amount of resistance you require in mind, you can move on to digitally rendering your circuit on Tinkercircuit. Tinkercircuit allows people to build circuits without the dangers of frying an LED or burning themselves. Once you have opened Tinkercircuit, pull a breadboard and battery into your workspace. Next, pull in your resistor, LED, and switch. While placing your components, keep in mind the configuration of a breadboard. The outside columns are connected vertically and the inside rows are connected horizontally. This picture of the inside of a breadboard shows these connections clearly. Notice how I lay out my components in intersecting rows. Now you can connect the components using wires. Connect the shorter end of the LED to the black column, which is the ground. Connect the end of the switch to the red column, which is the power. The red is positive and the black is negative. This is similar to the schematic we made earlier. To see if your circuit works, press the simulation button. The final step is to create a physical rendition of your circuit on a proto board. Gather your components: a soldering iron, a proto board, goggles, steel wool, solder, a multimeter, and pliers. To find the resistance of an LED, connect the resistor's legs to the probes and set the resistor to the ohm setting. Since this is a 100 ohm resistor and resistance adds in series circuits, I use 4 of these resistors to create 400 ohms of resistance, which fits the calculated 350 ohms. Soldering irons can reach around 750 degrees Celsius, so keep your fingers away from the soldering iron to prevent burns. Arrange your components in the order of your Tinkercircuit. Then, touch the tip of the soldering iron to the rim of the metal circle on the proto board and melt the solder onto the rim. The solder is a conductor and will allow electrons or electricity to flow from component to component. This zoomed-in clip will show the process in greater detail. When there's too much solder in your soldering iron, wipe it off in the steel wool. Initially, soldering will be time-consuming, but with practice you will improve. Use wire cutters to clip the components' legs. To connect components, you will need to make a solder bridge. A solder bridge is created when you apply excess solder between 2 previously soldered points. If you notice brown residue on your board, that's okay. It's simply the flux from your solder. Flux helps to clean your components and help things connect better. This is what the back side of my proto board looked like after I was done. Your solder bridges will most likely turn out messy, but that's okay as long as there's strong connections. To turn on your circuit, place the battery in the battery holder and flip the switch on. Congratulations, you've just made an LED circuit. In the future, you can apply this process analysis to more complex circuits.